A rational function is simply a ratio of two polynomials, such as f of x is equal to x plus 2 over x minus 5, or g of x or h of x from the packet. Basically, it's like if we take one polynomial and divide by another, sort of like we discussed back in chapter 4 when we learned when we were reviewing synthetic and long division of polynomials. Basically, it's the combination of those two polynomials in a singular function. And it's sort of like comparing a number to a fraction. There's always a little bit more complexity. And what we're going to be focusing on in this chapter is, first of all, how do we add, subtract, multiply, and divide these sort of things together? And basically, it's all about applying the rules for fractions to that of polynomials. And there's a lot of similarities. And a lot of the time involves factoring. So chapter 5, very critical in skills for chapter 6. And then, of course, we're going to talk about solving equations and how these things are relevant in terms of inverse proportionality, in terms of distance equals rate times time, and with related rates, as we often call them. But to begin with, a rational function often has problems with the domain due to the fact that we have division, right? As we discussed when we were talking about domain initially, dividing by 0 causes a mathematical problem where if you were to divide by 0, you would get something that is undefined. And the key thing with a function is predictability having an outcome. So if we get an undefined answer, that implies that that value was not in the domain. So say, for example, looking at f of x in this case, let's just say we were going to plug in 0. And also, another thing about if we were to graph rational functions, we're not going to focus on that in this chapter, is that, if we wanted to know, well, where's the y-intercept, it's always going to occur at f of 0 in any function. And let's just say we wanted to know what that would be. In this case, I would have, well, just as usual, I'll just plug it in. 0 plus 2 over 0 minus 5. And I would get, well, 2 over negative 5, which is equal to negative 2/5, or negative 0.4. And it's not surprising that when we evaluate a rational function at particular values, often we're going to get fractional results, just because, in essence, it is comprised of division. But, again, we could plug in wherever we want, and this function would be well-defined at basically everywhere. Though there is one position where this function would be undefined, is specifically if I were to plug in positive 5. Because if I do that, well, on the top I'd have 5 plus 2, and the bottom I'd have 5 minus 5. On the top I would get 7. But of course, the reason why 5 doesn't work is because in this example, the denominator is a linear factor of x minus 5. And we all know that the 0 of x minus 5 is positive 5, because 5 minus 5 is 0. And, when I plug in 5, that gives me something 7 divided by 0, which, recall, is an undefined result. Because dividing by 0 is not allowed in mathematics. It just doesn't make sense to do. And again, what that kind of implies is, okay, when I get an undefined answer, that just means that as well, 5 is not within the domain. So one of the things you're going to be asked to do in this first section of homework is figure out the domain, or find the undefined values as it were referred. But a lot of times we write that like this, because since 5 is not going to be defined in this rational function, we often would express that as x is not allowed to be 5, and we'd say that that's the location of the undefined value. But at the same time, the domain would be in, I have a little step-by-step instruction on the packet, which, instructs you about how you can do it in a more step-by-step manner. But step 1 is to find the undefined values by setting the denominator equal to 0, as we did in that first case. And it says to use the not equal sign instead, because we're not allowing it to work. And it says solve the resulting equation if necessary. And we'll look at some examples that are a little harder, like with g and h of x. It says the domain will be all real numbers except for those in step 1 to 2. So if you recall how we could write this in interval notation, what I could say is that it's, if I was trying to figure out, well, what's the domain, all reals, I could always write it out in a sentence. And it's better to write it out in a sentence if you don't know how to do it in interval notation. But the MyMathLab, as with the first test and with the homework, always, prefers you enter your answer as interval notation. And I could kind of write it that way, but in interval notation, remember how we write that as well. We want basically all the numbers, from negative infinity to infinity. But in order to insert a gap in our domain, what we can do is we can say, well, it's all real numbers less than 5. Those are all part of my domain. And it's also the union of that with all real numbers greater than 5. not including 5. And what this is sort of saying is that, well, we have every single number in here between negative infinity and 5, which is just, you know, x less than 5. And this is x greater than 5. The joining of those two would give me everything except for 5. And, you know, that's kind of the basic idea. So if you tried to sort of summarize, set the denominator equal to 0, and remove those from your number line by putting them in between negative infinity and infinity. So let's look at another one. Let's say, for example, with g of x, we wanted to find the domain. Well, I wouldn't necessarily have to do what I did here. I was trying to say, how do I evaluate? Works the same as any other function. And, you know, my illustration here was that we can run into problems. But let's say we're dealing with a more complex set of polynomials, like with g of x. Here, it would be anywhere that would make the denominator equal to 0 that would be undefined. So again, because the top being 0 is never a problem, because 0, like going back to f of x, let's say I was to plug in -2 here, that would give me 0 over -7. Well, 0 over -7 is 0, because you can take 0 and divide it up. You just can't take a number and divide it into 0 parts. So all that being said, when you're trying to find the domain, you only care about the denominator just because that's the only problem area. But in this case, you know, what we can see is that it's a degree 3 polynomial, which implies that there are probably more than one. There's probably more than one undefined value in this case. But basically what I could do is I could write a polynomial equation, set it equal to 0, solve. And as we discussed in chapter 5, well, to do this, we need a factor. So if to factor this, I could factor out the GCF from this term, which would leave me with x squared minus 4. And then since x squared minus 4 is a difference of squares, it would factor as x plus 2 times x minus 2. And this leaves me with 3 answers. And I'm going to use x cannot equal, because again, what we're finding is technically this equation I'm writing, when does it equal 0? But my conclusion is that x cannot be 0. And x cannot be -2, and x cannot be 2, because each of those 3 factors would result in a value of 0, which is undefined. So in this case, we actually have 3 undefined parts to our rational function. And so if we were trying to figure out what's the domain of g, and, you know, just to, let me keep better notes here, that first one's the domain of f. The domain of g would be all real numbers except for 0, -2, and 2. And, you know, if I was going to write my interval notation, I would always do it from left to right. So basically, I would want to take all real numbers smaller than -2. Also, all numbers between -2 and 0. All numbers between 0 and 2. I'm running out of room on my tablet. And then all numbers from 2 to infinity. And this would describe basically every single number except for those 3. And it's kind of like I'm inserting a gap in there. And another way to think about this, if you're having a little bit of trouble with how I'm generating all of these answers, basically what I'm doing in my brain is kind of thinking about a number line and thinking about what it means to extract a particular answer. Because basically, any potential number, including fractions and decimals and other whole numbers, any number is going to work in here except for those 3 very specific things. So on the number line, I'm kind of imagining, well, how I would remove 0, I would remove 2, and I would remove -2. Those 3 positions are basically not included as my solution. But anything larger than 2 will be fine. Anything in between 0 and 2 will be fine. Anything between -2 and 0, and anything smaller than -2. So it essentially breaks up my set of all real numbers into 4 distinct parts. Each 0 in the denominator breaks it up into an additional interval. So, you know, having 3 undefined values means that I have 4 intervals. And it's just separated between -infinity and infinity, breaking down each of those other components. And let's do one more. I'm out of room in here, but let's say for h of x, I wanted to figure out the domain of h of x. Again, gist of it is I want to figure out when the denominator is equal to 0. So I want to factor it. And technically, you don't even need to write an equation if you just factored the denominator. Here, the denominator was 2x squared minus 11x plus 14. But I'm going to go ahead. You could also write it like this and say that it's not allowed to be 0. That's probably a little bit more proper because it's the same sort of idea there. But, you know, it all kind of comes down to the logic within an equation, and, you know, just tying it back to an equation, gonna leave it the way it did before. And then I would need to factor this. So we could use a magic x here, but I'm going to use the guess and check method just to be a little bit faster. And this would leave me with -7 and -2. No, that's not going to work. Actually, let's see, 14 is also... I'll just make a magic x because for some reason I'm getting a little bit stuck with this. So I would put 28 on top, -11 on bottom. 28 is the same as 7 times 4, so I would need -7 and -4. And that makes sense. So if I split the middle term, I'd have 2x squared minus 7x minus 4x plus 11. And from the first group, I have a common factor of x, which would leave me with 2x minus 7. And in the second group, I could factor out -2, which would leave me with 2x minus 7. And so, you know, reiterating the technique of factoring trinomials from chapter 5, I can use the magic x method and split the middle term to factor by grouping, which would leave me with the full factorization of x minus 2 times 2x minus 7 is equal to 0. And again, the whole point of this is I was trying to figure out the domain of my h function. So I figured out now where the denominator is equal to 0. X is not allowed to be 2, and x is not allowed to be 7/2. And again, my domain of h would be all reals except for those two. So all reals up until 2, and all numbers in between 2 and 7/2, and then all numbers greater than 7/2. And this would give me my